Hi there. Have you heard about the recent technology incorporated in automotive sector? Well, that is called EMS Engine Management System. EMS is a type of electronic control unit that controls the running of an engine by monitoring the engine speed and ensure optimal engine performance. Technically, the engine management system is responsible for controlling the amount of fuel being injected and for adjusting the ignition timing. Here, optimum functioning of the EMS assures maximum engine power, with the lowest amount of exhaust emissions and the lowest fuel consumption. It means it measures the exact quantity of fuel required to start an engine. Why car need an engine management system? Actually, it is required to manage the powertrain inside the engine. And it also helps to maintain proper coordination with an engine's ignition system, fuel injection system, and emission control. In short, it helps to maintain a right coordination within the engine parts so that it will give better output. Let's discuss about the key parts. They are electronic fuel injection system, air induction system, fuel delivery system, electronic control system, electronic control unit, fuel injector sequential, airflow sensor, air temperature sensor, throttle position sensor, temperature sensor, oxygen sensor, idle air control valve, MAP sensor, NOx sensor, engine speed sensor, engine oil sensor, crankshaft sensor, camshaft sensor and multi-point fuel injection. First, electronic fuel injection system. This is the primary fuel delivery system which determines the amount of fuel to be injected into the engine and when to fire the spark plugs. This information helps the engine to achieve the most horsepower with the least amount of fuel. Air induction system. The purpose of the air induction system is to filter, meter and measure and take airflow into the engine. Fuel delivery system. It helps to inject the correct and precise amount of fuel in the intake manifold. It measures the exact fuel efficiency, emission performance and engine tuning, etc. Electronic control system. The purpose of electronic control system is to detect air temperature, engine temperature, throttle valve opening angle, amount of air entering to air induction system, etc. The system controls the correct amount of fuel to be injected and the proper time at which the fuel will be injected at any speed and load condition. Electronic control unit. The electronic control unit serves as the control center for all of the sensors on a car. It controls more than one electric system and subsystems in a motor vehicle. That's why it helps in regulating and maintaining the amount of fuel and air that is needed by engine to increase horsepower. Fuel injector sequential. It's a type of multi-port injection system in which injection valve will open just before the cylinder intake valve opens. It has the fast response time when the driver makes a quick change at the time of driving. Airflow sensor. An airflow sensor is a device that measures the actual speed of the air flowing through the engine in different segments. Generally, it measures the mass of air flowing through the device per unit of time. Air temperature sensor. Actually, it helps to measure the air density for fuel mixture control and to trim the airflow ratio according to the airflow density. Throttle position sensor. The sensor is used to monitor the throttle position of a car. The sensor moves with the throttle and sends a voltage signal to the computer indicating throttle angle and speed of movement. The computer uses this data to measure engine load, adjust timing, fuel delivery, etc. Temperature sensor. Temperature sensors include analog and digital sensor ICs designed for temperature monitoring of a system. Oxygen sensor. It measures the proportion of oxygen to fuel in the engine. The idle air control valve. It's also known as idle speed control valve. Regulates the idle speed of the engine. MAP sensor. This sensor measures air pressure which shows engines the current altitude of a vehicle. NOx sensor. The NOx sensor detects engine knock and sends a voltage signal to the engine and the engine uses that signal to control the timing. Engine speed sensor. An engine speed sensor is attached to crankshaft of car's engine and it indicates the speed that the crankshaft is spinning with. This information is beneficial to control both the ignition timing and EMS. Engine oil sensor. It measures the oil pressure inside the engine and gives an alert in case of any problem with oil pressure. Crankshaft sensor. It is used to monitor the position and rotational speed of crankshaft, and this information will be used by the EMS to control the ignition system timing and other engine parameters. Camshaft sensor. The camshaft sensors determine which cylinder is firing to establish injector synchronization and coil firing sequence in DIS systems. Then the crankshaft sensors set ignition timing, supply the RPM signal and measure the engine speed. Multi-point fuel injection. In EMS, each cylinder has a number of injectors to spray fuel in the cylinders as compared to one injector located centrally to spray fuel in case of single-point injection system. Through the use of MPFI, you will find more uniform air-fuel mixture supplied to all cylinders in your engine, and this uniformity of air-fuel improves the mileage of the vehicle. Thank you for watching the video.